Hello, the topic of today's lesson is algebraic equations. We worked with expressions in the last few weeks, and finally we're getting to equations. So what is the difference between expressions and equations? Algebraic expression or mathematical expression is simply a phrase. It's a phrase. It's like a mathematical sentence that contains numbers, variables, operations, but no equal sign. Equations have the left-hand side and the right-hand side. And they are in balance. They're equal. What you have on the right, you must have on the left, and what you have on the left, you must have on the right. Let's practice equations. Or mathematical statements that contain the left and the right, separated or balanced with an equal sign. Let's read the first example. There's six more girls than boys in a class. How many girls are there if there are 12 boys? So, step one, what is the problem talking about? Boys and girls. What does the problem tell us? There are 12 boys and six more girls, plus 6 more girls than boys. It's a second grade word problem, right? Second grade word problem. So how many girls are there? Well, super simple. 12, it's a one-step word problem. 12 plus 6 equals 18. There are 18 girls, of course. Next problem. There's 6 more girls than boys. Again, we have more girls than boys, so it's plus 6. If there are 30 children, this is the total. If there are 30, the 30 children altogether, how many girls are there? It's a multi-step problem. Step 1, get rid of the difference. 30 minus 6 equals 24. What did we find? We found that these two units, okay, are now 24. These two units are now 24. And so to find each of them, we have to say 24 divided by 2 equals 12. So each of this is 12. Therefore, the number of girls, step 3, is, because there's 6 more, is 12 plus 6 equals 18. Now, let's bring this problem into algebra. Let the number of boys be x. Okay, let's solve this problem with algebra. How many boys do we have? X boys. Of course, what is the number of girls? X plus 6. Altogether, we have 30. It is a two-step problem. Again, 30 minus 6, then divide by 2, and just like we had the solution, let's practice it on our own examples. Page number 15. There are two numbers. The first number is 4 times as much as the second number. So the problem is talking about number 1 and number 2. What do we know about these numbers? 1 is x. Let the smaller number be x. Then the other number is 1 times x, 4 times x, 3 times x, 4 times as much. Or 4 times x, we write it 4x. Remember, 4 is called a coefficient. That's the number in front of the variable, coefficient. We can write 4 times x, but in algebra, we drop the dot and we just say 4x, but it means the same thing. So, if the first number is 20, if the larger number is 20, what is the second number? Well, let's translate our drawing, our English into algebra. 4x is 20. The larger number is 20. Therefore, how do we find a smaller number? I'm sure you know the answer. 4 times what makes 20? X equals to 5. So this has to be 5. In fact, each of these units, x equals to 5. The second number is 5. And next example. Find the value of x when 3x is equal to 15. Well, if 3x is 15, how much is 1x? Well, it's going to be 3 times less. 3 times less. What do? We divide by 3, and the answer is 5. X equals 15 divided by 3. Now, we have another example. X plus 3 equals 15. I know you can solve it using mental math, but we're trying to get to same type of approach. What plus 3 gives you 15? We can use the visualization with bar models, but I will teach you one sure method to solve most equations, one-step equations. X, so let's write it down right here. X plus 3 equals 15. We're going to solve this equation by isolating the variable. Isolate the variable. What does that mean? It means we want the variable, in this case it's x, stand by itself on the left-hand side. What is in the way of our x to be by itself? We have x plus 3. We have to use inverse operation or opposite operation to get rid of the 3. What is the opposite of plus 3? Minus 3. However, the rules of equations state what you do to the left, you must do to the right. We have to balance our actions, otherwise we lose the balance, we lose the equality. So, what do we have? Plus 3 and minus 3 reduced to 0. Cancel each other out. Now we have x all by itself on the left-hand side. What do we have on the right? 15 minus 3 equals 12. And we do know, of course, you knew that from before, x equals 12 was always the solution. It's the only value that makes this equation true, meaning what we have on the left, we will have on the right. 12 plus 3 gives you 15, and 15, of course, they're equal to each other. Let's consider example number 4. What minus 3 gives you 15? What reduced by 3 gives us 15? You can look at the bar model or you can think logically. We know this must be 18. However, I would like to introduce you to solving it with the same method. I'm going to write it down again. Isolate the variable. That's the method we use for solving one-step equations, even two-step equations. We'll get to that later. So, in order to isolate the variable, what do we want? We want x. So I'm going to write it down. Copy it right here. X minus 3 equals 15. We need to make x stand all by itself on the left-hand side. Well, what is in the way of our x? Minus 3. How do we get rid of it? We use opposite operation. Opposite of subtraction is addition. According to the rules of equations, what we do to the left, we must do to the right. So we must add 3 to the right-hand side. What happens on the left? Minus 3 and plus 3 reduces to 0. We have x by itself. And what do we have on the right-hand side? We have 15 plus 3, which is 18. X equals 18 is the only value of x that makes this equation true, that solves this equation, that balances this equation. Let's take a look at number 5. Y minus 5 equals 11. Let's think about it logically. What reduced by 5 gives us 11? Well, can we copy it and solve it the same method? We're trying to understand the solution. Isolate the variable. What does it mean? Variable y has to be by itself. What is currently in the way of y? We have minus 5. In order to get rid of minus 5, we need to use inverse operation. Let's add 5. What we do to the left, we must do to the right. Otherwise, we lose the balance. Minus 5 and plus 5 will reduce to 0. And we will have y standing by itself. On the left, beautiful, that's what we wanted. What do we have on the right? 11 plus 5, which is 16. Y equals 16 is the only value of y that makes this equation true. Let's consider the next equation. 7 minus x equals to 4. 7 minus x equals to 4. Now, this equation is very different. What? 7 minus what reduces it to 4? We know the answer must be 3. But how would we solve it using our method of isolating the variable? Step 1. Let's make sure that minus x is by itself on the left-hand side. Minus x equals, well, what is in our way? Of course, the 7. How do we get rid of it? We use opposite operation. Minus 7. 7 minus 7 gives you 0. What we do to the left, let's not forget, we must do to the right. 4 minus 7 gives you negative 3. What do we have? Negative x equals negative 3. Except we never wanted to solve for negative x. We need to solve for x. We must negate the answer and look at the opposite. Therefore, if negative x equals negative 3, positive x equals 2, 3. We will get into more details of this in next lessons in algebra. Otherwise, let's continue. Next equation, 20 minus y equals 11. Again, let's solve it by isolating the variable. Minus y equals, well, what is in the way of negative y? Of course, this 20. How do we get rid of it? Let's use opposite operation. Minus 20. This will get rid of 20, right? We'll reduce it. We can put the cross through it. However, what we do to the left, we must do to the right. 11 minus 20 gives you negative 9. What did we get? Negation of y equals negative 9. How do we find positive y? That's opposite, right? Therefore, y must be equal to 9, which of course we could figure out logically. That's the only solution to this equation. Now, let's take a look at the next equation. Number 8. 1/3 of x equals 15. 1/3 of x. I hope you remember that 1/3 of x can be rewritten as x divided by 3. We can think of it like that, equals 15. What do we do to isolate x and make it stand by itself? Let me keep writing it. Isolate the variable. How do we isolate the variable? One more time. For example, number 8. Well, x is on the left. What is in the way of x? Divide by 3. What is the inverse operation of division? Of course, multiplication. We must multiply 3 times. By the way, this is not 3x. 3 times x over 3 on the right, on the left. What we do to the left, we must do to the right. Look what's happening. On the left-hand side, 3 times divide by 3 will cancel down to 1, which is what we want. We now have x, 1x by itself. What do we have on the right? We have 45. Now, x equals 45. Let's see if this answer makes sense. 1/3 of 45. 1/3 of 45. Does that equal to 15? Yes. 45 divided by 3 is 15. We solved our equation, 45. And finally, answer number 9, or problem number 9. 1/4 of y equals 3. Again, let's continue using the same strategy. Isolate the variable. 1/4 of what equals 3? Well, we want y by itself on the left-hand side. What is standing? 1/4, or divide by 4. What is opposite? How can we come up not with 1/4 of y? We need y. We need y by itself. Well, we need to multiply it by 4, of course. What we do to the left, we must do to the right. On the left-hand side, 4's will cancel out and we have y by itself. And on the right-hand side, we have 3 times 4, which is 12. Let's go back and see if our answer makes sense. Is 1/4 of 12? 1/4 of 12, does it equal to 3? Yes. Therefore, we